Next, we will discuss what the ideal independent voltage source is in the case of the small signal. We draw its UI feature. First, because it is a voltage source, so it is impossible to produce delta US. The only thing that seems to be possible is that there is a delta U with the existing delta I. Similarly, delta U equals dUs over di at the time of I equals I0 times delta I. Look at it. Because it is a straight line in the UI plane, the value must be equal to 0. So it is a zero resistor or a short circuit line in the small signal model. A relevant component is the ideal independent current source. We draw its UI feature here. Similarly, because it's a current source, so it's impossible to produce a small current signal. The only possible way is that there is a delta I with a existing delta U. So delta I equals dIs over du at the time of U equals U0 times delta U. For such a straight line, it is 0. So it corresponds to a zero conductance, that is an open circuit. So the ideal independent voltage source and the ideal independent current source are equivalent to the short circuit and the open circuit, respectively, in the case of the small signal. It's very important for solving problems. Please note it. Next, we take the linear voltage controlled current source as an example to show how the linear dependent source is expressed in the small signal circuit. Assuming there is a small change in the controlling quantity U1, that is, delta I equals dGu1 over du1 at the time U1 equals capital U1 times delta U1. Because dGu1 du1 is a constant value G, so it is G times delta U1. We can find that in the case of the small signal, it is still a linear voltage controlled current source, and the controlling quantity does not change. If here is a nonlinear dependent source, we take the nonlinear voltage controlled current source as an example. Similarly, we have delta I equals dF over du1 at the time of U1 equals capital U1 times delta U. Because f is a nonlinear function of U1, it is a value changed with different working points. So in the case of the small signal, it is equivalent to a linear voltage controlled current source. We will use this conclusion in the next lecture when discussing the MOSFET.